Okay, everyone. I'm about to get started. I just sent a link to a Google Drive where we can see the code and the data files. Does everyone see that? If you cannot see it, can you let me know in the chat? They, if you wish to follow along with some of the code for introduction to introducing to Python and then some of the data pre-processing skills, you'll need to you can click this link, and then you would want to if you look at my screen, you'll click that link, and then it'll take you to the folder, and then you want to click add shortcut to drive. Click that, and then make sure you add the shortcut to my drive. And then you should be able to, when clicking on these files, you should be able to use any of the data sets automatically. Does anybody have any questions? Okay, I'm about to get started. So again, I'm introducing Python and data processing skills. We will go over a few packages and then talk about data frames and then image data. This is aimed at just providing like kind of a crash course into understanding Python and provide some background knowledge. So here we will be using Google Colab, and the reason we'll be using Google Colab is because you don't have to install any packages or software on your computer. Most people, Google Colab is more frequently used to present code, but a lot of people do their processing elsewhere on Anaconda, where we've downloaded Python, and this is where the interface looks like, where we can launch different software. We can launch different softwares and download different packages into our environments. But for the sake of this presentation, to be able to share this information, I'm using Google Colab. And so I've attached this Anaconda installation guide here for anyone that wants to download it. And then, so now we're going into overview of Python, where I will talk about the different data types, comparison operations, if, elif, and else statements, for loops, while loops, ranges, list comprehension, and then functions. So here to start on the basics of it, we can perform basic arithmetic, where we use addition, multiplication, division, and then we have exponent operations. And then we can also tell whether a number is even or odd by using this percent value here. So if a number, for example, if a number is even, it'll always output a 0. While if a number is odd here, it will output a 1. And the same thing could be used for determining if a number is divisible by 3 or divisible by 4. We can use this same percent operation. Next, we have variable assignment, where we can assign these numbers and then perform mathematical operations within to these assigned variables. And then the next type of data type is a string, so we can have phrases or groups of words. These are these operations. We sometimes have words like the name of something or some type of category, and we can start to manipulate those string values within Python. Next, we can print values where I used my name and my soccer number, where it's my number is 28 and my name is Christian. We have a variable assignment here, and we have the location of where that variable will appear in the phrase by using 1 or 2, where we have located it using these. We've determined the location using these brackets within the print statement. Next, we'll go on to lists, and lists are something I use frequently within my coding, where we have we put values within this data type. So we have 1, 2, and 3, and we start to index at 0 instead of 1, which just can be confusing for a lot of people, and this is not always common in every type of coding language. So we've indexed my list using 0, and we've determined that, and that found the first value within the list. That's printed here. And then we've used the next index 1, where it's printed the second value within the list. And this is also done. This type of indexing is done throughout Python, whether you're using a data frame or a tuple. And then so we can append new values to the list using this append function. So we've added the 4, and then we used the dot remove to remove that value from the list. Next, we have tuples, which it's very similar to lists, but the main idea is that they are permanent and they do not change once they are defined, and so we cannot add new values or change the value within this tuple, and it's defined by these parenthesis brackets here. The list, you can see the lists are defined by these square brackets, and tuples are defined by the parenthesis brackets. So, and then we can index the tuple using the same operation as a list. Like, another big difference between a list and tuple is that the big thing is that they cannot be changed. That means they're immutable. Next, we go on to dictionaries, where we are defining certain keys and then their items. So the key, like a key value, could be anything defined on the left side of this operation. And then so we use this our dictionary dot keys to define the names of our keys, and then we dot items to define the whole item. And then here we can print that first key by using the name. So here we have the dictionary is done by the key names, and it's printed item 1, and we can change whatever the value is, the item. We don't have to use a string. We can use a number, where we have key 1 is assigned to 1, and so it has printed that first key item, which is 1. I can change that value. I can say here I want to print the second key value. So here now I've got key value is 2, and the same operation is done for this dictionary. The next type of data type is a Boolean, which is just true or false. These are used frequently within the programming to be able to say, like, based off certain operations, is this true or is this false? And then we can use that to help assign or index a data set. And then this will be further discussed. This is going to be further discussed in some of the other operations. And then we have sets, where we use these brackets to define the set. And the sets preserves only the unique values. No matter how many different values we put into the set, we're going to always get only the unique values. Now we're moving on to comparison operations, where we want to know whether a value is greater or larger than another value, or whether it's equal to, and then we can assign values using a double equal sign, or we can determine if a value is equal to something using a double equal sign, and then assign using a single equal sign. So here we have our first operation where 1 is greater. So we're trying to see if 1 is greater than 2, and it prints the Boolean value false. But when we say 1 is greater than or equal to 1, we get the Boolean value is true. And then we have and then we also can use these two string values, and we want to see if those two are equal to each other or not. And so we find that they are not, and we don't have to use strings. We can use different variable assignment and determine whether they are equal. Next we have the logic operations, where we use and statements to determine if it only prints true if both are true, or we use an or statement that prints true if at least one of the statements are true. So here we have the and statement. 1 is greater than 2 and 2 is less than 3. There, but one is true and the other is not, and so we get false. So, but when we use the or statement, we find that 2 is less than 3, which prints a statement as true. So the next type of operation in Python are if and else statements. These are basic conditional statements, and if condition is met, then it will print a certain operation will take place. So if we have the same, if 1 is less than 2, we print yep, and then else we print no. So obviously we have 1 is less than 2, so we print yep, and on the other hand, when 1 is not greater than 2, we print no. We can further use this operation and implement multiple conditions with using this elif statement in the middle, where if a is equal to 2, we print first. If elif is equal to 3, we print in the middle, and then else we print last. So here a is equal to 3, so we print in the middle. So if I change the number to 5, it's going to print last. Given it's taking a second to run. And if we change a to equal, it'll print first. So these are the conditional statements that are commonly used in Python. We have ranges where we're trying to find the range between two values. So we use the range between 0 and 5, and if we print a list, we find the values between 2 and 5, which are 2, 3, and 4. So this, as you see here, this operation doesn't bring the last value 5. It stops at the value before 5. So here we have 1, 2, 3, 4. Where otherwise if we change this value to 6, it'll add 6 to that list, and then we can see the length of that list as being 3. So next we have the next key operation, which is for loops, where we're trying to iterate through a list or a data frame or a Numpy array. We can iterate through that whole entire set to and conduct operations on that set. So, for example, we have the sequence 1, 2, 3, 4, and 5. We will just print with the for loop. I will become the first iteration, then the next iteration, and so on until it goes through the whole entire list. So we have for the for loop printed 1, 2, 3, and 4, and 5 in different iterations. So if I added a print next operation, it will put that in between, and because it's going through the whole for loop is printing all these statements and then circling back. And we can also do this. We can also conduct this for loop using the length of the list as to determine how far to iterate, and then we can use that the sequence value to determine the location. This is where you can index these lists to determine which value we want to perform operations on. We can also change this to raise it to the power of 2. So if we do that, this operation, once this code completes, it's taking a second, but we can conduct the operations and get the next, and we'll get each value raised to the power of 2. Next, we have list comprehension, where we can start to we can perform those operations and add them to a new list. So we have our original list, and then to append values to the to a output list. So we have that same operation as performed above, but where we raise values to the power of 2, but it's in a whole new list defined as out. Lastly, we'll go with defining our functions. So here I will define a function that lets you know whether a value is even or not. So I define this function with an if-else statement in it. So if the input value is even, it'll print true and then return that value. Else if it's not even, it'll tell you false and it'll return that value. So here I have if even is 3, it returns false and 3. And if I put 2 in there, it returns true and 2. And then I can define another function and use that function that I've defined within this next operation. So this, as you see here, the if even is within the is in this new function where the I value will be the Boolean true or false value, and then this Y value will be that returned X value. And here with this if statement, if I is true, we'll divide by 2. If the value is false, it'll be multiplied times 2. So here we have, if we have we use our function and we use the value 4. So 4 is 4 is even, so we divide it by 2 and we get the value 2. So, but if we change it to 5, we have multiplied that value by 2 and we get the value 10. So that's some of the basic operations within Python and data types. Now we'll be moving on to some of the data science methods where we talk about a few important packages such as Numpy, Pandas, and Matplotlib. Numpy has some of the mathematical operations and is good for handling multidimensional data, where Pandas is good for manipulating data frames, and then Matplotlib is our package for visualizing our data and being able to explore different, being able to look data analysis and explore what is happening within our data. So we've attached a few resources for anyone that's wanting to further investigate how to code in these modules. This is not going to provide all the information, but we're trying to provide some key ideas and methods used for with the objective of being able to perform data analytics and data science. So with that being said, we'll start with Numpy. Here, before I even start that, I've mounted my Google Drive so I have any of my data sets that I've attached here to help explain some of the data sets have been attached to that we will be using it later in this code. So for Numpy, it provides the ability to perform operations on matrices, and it's a very popular, powerful and popular package. Here, so we have the difference between an array and a list can be seen here, where we have there's a comma between values within each different data type. And then then a 2D list can be transformed into a 2D array that can be seen here. The 2D array can start to represent the larger the array, can start to sheet like the images and different is how we represent images within our data set. And now we can start to index the 2D array by this is the second row, second column. So we have our second row, second column, our third column, second row, third column where we get 6, or we can find all the values in the second column, which we can see here. We can find whether we can print the Boolean values for all values greater than 5, and then we can use this indexing to return all those values that are all those values that are greater than 5. We can perform matrix we can multiply the matrix, every value in the matrix. We can square root every value in the matrix, and then we have the following more mathematical operations that can be used in Numpy. And then we also have these linear algebra operations that can be further explored if you're interested. And now we can start to form more operations on arrays where we can print the values between 1 and 10, and then we can find 5 values between 1 and 10. We can print 10 0 values, 7 1, and then we can prevent how many one values we want in the list. We can print a whole array of zero values. We can create an identity matrix using this I function. We can print 24 different values. We can reshape those 24 different values into different sizes, where we go 3 by 8 or 4 by 6. Or 2 by 12. There's just multiple different ways we can reshape it, and manipulate our data. In some machine learning packages for image processing, for example, we want to flatten our image, so we will change it by 1 by 24, and this helps in some methods. We also have this ability to generate random numbers between 10, generate random numbers between 1 and 20. We can find a number of we can find random values with a mean of 0 and a standard deviation of 1. We can print 10 different numbers. We can find all these different random values between 10 and 200, and then we can determine which value is the max, which value is the min, and then we can find the index location for these values as well. So that's finishing up with Numpy. Again, this is expected just to be a crash course and provide some ideas of what we can do with Numpy. So next we go into Pandas, which is popular for data processing, where we can import different CSV files and data frames, and then we can also this can be extremely common in machine learning, and we can really start to manipulate data sets and see the data set in a visually comprehensive way. So now we have imported this iris data set, and we can show the first five columns, the first 5 rows, last 5 rows, with all the different columns where we have sepal length, petal length, petal width, and then the species. These are all numerical continuous values, while this species values is a string value within the data frame. Also, we can share the data frame just look at the entire, or a condensed version of the whole data frame, but this is give you an idea how many rows and how many columns are within the data frame. We can find the columns. We can find we can use this. We can turn the pandas data frame into a Numpy array, and then find the first five values. We can transpose the data frame where we've basically flipped the data frame. We can sort all the values by a certain value. So we've sorted by sepal length, where we start with the minimum value and go to the maximum sepal length. We can use .describe to find descriptive statistics of each column. We can change the index, because originally we indexed from 0 to 149, but now we change index from 1 to 150. And so now we're finding the first value. We're finding the first value with it. And we can use this uses .lock to index the data frame, where we can .lock is used when we use a string value to index. And then we have .ilock to use this is used to index find the index location with just numbers. So here we have the first row and then the first column. So we found this value here. If we change this to a 1, we have the first row or first observation, and then second column. So now we've reset the index, and and then we've moved on, use the head function to find the first 5 values, and then we can index in numerous ways, where we find here where we're manipulating the number of rows we want to see and the number of columns we want to see. Again, it's similar to the list. The third row will not be shown. It's going to stop right before the third row. Same here. And then we can find the shape. So we have 150 observation 5. And we've printed the entire, and we've printed all points. We indexed the whole data and only the species of Sisota. And or we can find all the values that have a sepal length greater than 4, index and create new data frames based off conditional operation. And then we can mathematical operations. We can add certain values together, like sepal length and length to get the sepal total, and then add that and create a whole new column here. And so that's to finish up the Pandas analysis on the iris dataset, where we've been able to really see some of the changes and manipulation within the data frame. Now we're going to quickly go over the visualization. So we can use so we've imported matplotlib, and we define it as PLT for to shorten up our code. And so we can create a line plot for using plt.plot. We can create multiple line plots and within one image using the using plt plot. And then we can use .scatter to just plot the different points. We can change what the markers within the different points look like. We can change the size. We can change the color. We can manipulate. We can add access. We can add all the access titles, and then we can create subplots within our data sets, and then with different we have these smaller plots to really show what the value to show the each column and where the value where the values have changed, and then create more, and then we can go into creating bar plots, pie charts, distribution histograms to show the distribution of the data within each set, and then we can start to show just a basic plot of just the different locations within a scatter plot, and then we can give those values color here, so we can see that we have its temperatures are hotter in the middle, and then or higher in the middle, and then move towards the out. As we move out from the middle, we get values that are lower, and we can define this by the color bar on the right. And lastly, we can use a three-dimensional tool to visualize this data. So that's what I have for the review of data science, and now we'll go over the pre-processing of a data frame. Again, if any of this is confusing or you have any questions, please feel free to ask at any time throughout this presentation. So now we're starting with processing a data frame where we have the So with Google Colab, I've mounted my drive and I've loaded a data set where we have cruise ship information. And so here's the data frame where we have multiple observations and multiple columns, and we even have some missing values within this data set. We use some descriptive statistics to really try to understand what's going on in this data set. For the descriptive statistics is only used on the continuous variables, where we have ship name, which is just that defines each ship that we're using, and then we have our cruise line. So we have data. So this is also shown through our data types, where these two are objects, which means they're not numerical values, and then we have all our continuous variables. So, and then we find the cardinality, which is the number of unique values within the data set. And so, now we were looking to find to remove some of the missing values, because to be able to use a machine learning algorithm, we cannot have any missing values within the data set, or we will run into errors. So here I found the number of missing values and the percent of missing values. And we want to, so for all these continuous variables, we only value, if it's over 10%, we might want to remove that variable. But if it's less than 10%, we can replace that with the median. So we can keep more information and more observations fed into our machine learning algorithm will better help our convergence to a local our global optimum. So we will replace that by using the median value, and see now we have zero missing continuous values, but now we still have a missing value within our categorical variable cruise line. And so an operation we can use here is to use forward fill or backward fill. So we use the forward fill is the last previous observation. We take that string value, or we have backward fill where we use the next string value to fill the missing value. There's other operations that can be performed, or methods that can be explored, such as like unsupervised learning techniques, to try to figure out what category that this cruise line would fall under. But this is a simple way at which to solve this problem, where now we have no missing values within our data set. But the next challenge that we run into is that for categorical so we cannot read, machine learning values cannot read string value, cannot read strings. So we have to turn that into a number, encode that into a numerical value. So by using the encoding categorical this encoding value, we found that we've assigned a number to each string. So whether we have Carnival Cruise is 1 or Star Cruise Line is 18, it's given a numerical value. This is, some machine learning methods can read these numerical values, but next we would have to use, but many times we have to now divide that into these categorical variables into their own dummy variables, where we create new variables that assign a 1 if an object is if that particular object is in that observation, and 0 for everything else. So this can be done with this one hot encoder operation, where we've created 20 new variables, where you can see that Carnival is assigned 1. Is assigned a 1 here for this variable, and where star at the end is assigned 1, and there's a 0 for everything else. And then next about data preprocessing operation I want to talk about is outliers, where sometimes our model isn't converging as well because we have an outlier that doesn't make sense within our data set. So to discover outliers, we can use a box plot where we can see there's a few outliers, within the data set, each variable, and we can use the z-score to locate the outliers that are far away from the mean, and then use a threshold value to remove those values. Here we have the row and the column where to help us index where it's located. And so we've used the z value to remove anything above to remove anything above 3. So all values less than 3 are still within the data frame. And so we've created a brand new data frame where outliers have been removed using the z-score. We can also use the interquartile range and remove any values outside the interquartile range, where we've defined the different quartile values using the df.describe function earlier in this code. And so using this, we've removed even more observations. Lastly, I'm gonna for this Python code, I want to finish up with combining data sets. So we have our final DF where we are variables in where we can use these columns and observations to process in a machine learning data set and a machine learning model. And then we can also save that CSV using the following line of code. So now we're going to our very last piece of code, where I will talk about some basic image processing and just different operations that can be performed. So again, I have all the packages, Numpy, Pandas, Numpy, Matplotlib. I've attached this OpenCV2, and then some mathematical operations. Here I've attached a few multiple images from my own research, where I can load 10 images of size 400 472. So here where these are large images and then are in a two-dimensional shape, and this and we want to read. I'm going to read that. I'm going to read those images and using Pandas and load the different CSV files that are labeled from image.c 1000, 1001, 1000, and we are going to load all those images and then input them into a 3D array where we have 10 images that are 479 by 752 resolution. So here are the different multiple images that I've loaded into the data set, loaded into Python. So we have all these images, but there's a high amount of noise. The multiple pool is a very small part of the image, and there's a lot of noise on the exterior parts of the pool. So I will now crop that. I will now crop that image into a smaller 10 images that are 100 by 116 resolution. So we can clearly now see the melt pool and see more of the information, and we can they're different elliptical sizes based on the direction of the printing process, because these melt pool images were collected from the additive manufacturing process. We can see the last image here has melt pool is has a lot of is having a lot of issues, and there's a problem with collecting this data. So for the first type of manipulation, to upscale your image. So I've collected that multiple image, but now I want to upsample it to create a higher resolution image. So I use image interpolation, where I use cubic splines to increase the dimensions by will double the size of the image resolution. And this is all done by smoothing. Next, we also want to perform feature scaling. So basically, we don't want certain variables to outweigh another variable, and when having values between 0 and 1 will help with the convergence of the optimizer. So you can either define your own scalar, which I defined here, and we get that we get the same image shape, but it's just between the temperature values are between 0 and 1, and then you can see that the distribution of the values is the same. Or you can use it's better, and it can, and it performs faster is using using other packages that pre-made packages for scaling, where I use this OpenCV2 to normalize the data between 0 and 1, and again it has the same distribution. Now I'm going to talk about a few other image processing techniques that we can try to implement on images, where it's all gathered from this OpenCV package. So first we'll start with edge detection, where we're trying to find the edges within an image. So we have our original image of a dog here, where we're using the subtle X to find the horizontal changes, and then subtle Y to find the vertical changes, and then we have that combined. And where for this particular image, it's difficult to see some of these edges, but we can use this Laplacian method, which detects edges with the local min and maximum using a kerneling effect. And then lastly, we can use the canny that removes noise and determines the intensity of the gradient. The next type of image processing method I want to go into is dilation, opening and closing, and erosion. So we have our original image, and we will be using and we can use this erosion method to detect to decrease the bright elements within this image, or we can use dilation to increase the bright elements. So we can see from our original image, the eyes and the dog's face have decreased here, while on the other hand, with dilation, the brighter elements have increased. We can have perspective transformations, where this is where we can rotate and move the image to find where to warp the image to what we want, or to find a certain location, or change the view of what we're looking at. So in this original image, we have a picture of a piece of paper, and we have changed it to only include the paper, not the desk or background information. This is commonly seen when, for example, when on the iPhone we have we can scan images into our scan images, and often it changes the perspective from and removes some of the background information when you're scanning it. And it also uses this thresholding method that we're trying to increase the we're trying to remove some of the we want to only highlight more of we want to highlight certain information within the image, and through from a threshold. So here we have our original image, and that's grayscaled, and then we have a threshold binary, where it's just a set value, or we have these different adaptive means of thresholding, and that we found here that the Gaussian YouTube thresholding achieved the best difference between background and on our piece of paper. Next, we have pyramid upscaling and pyramid downsampling, where we can downsample the size of the image using these pyramid schemes, where we're downsampling instead of using like a smoothing, we're using a kernel. This kerneling and coefficients, where the coefficients help to keep the edges within the image. So it's downsampled to see the resolution of the image has decreased, and then we can, with this Gaussian pyramid downsampling, and then we can use this Laplacian upscaling pyramid, and it creates a larger image, but it's not as clear as the original, but it has still kept the shape of the object. Next, we have sharpening, where we use a kernel to sharpen certain values. You can see that some features are brought out more distinctly with this sharpening. We can use blurring, and this is also based off a kerneling method, where the size of the kernel matters how much blur is put into the image. You can see the 7x7 kernel blurs the image even more. But sometimes with machine learning methods to help with convergence, intentional blurring can help the prediction accuracy. And then lastly, we can use these contours with edge detection in our original image. So we have our original image here, and then we can determine those edges and then add those contoured edges to the original image. This still isn't. There's some manipulation and different things that can be done to better improve the contouring and the edge detection, but there's still more improvements to be made on this image processing. So to finish up, that is the rest of my coding examples and intro to Python programming and data processing. For anyone that is interested in getting more information about Python, you can feel free to ask me questions, and you can look at my code within the OneDrive link that I've shared in the chat. Thank you. Anybody have any questions?
Thank you, Christian, for giving a good lecture on Python.
Thank you guys for attending, and this video will be recorded and put it on our YouTube account. Thank you, everyone.